Imagine a web of interconnected nodes, each one buzzing with activity, processing information like a brain. That's the essence of neural networks. They're inspired by the way our brains work, designed to recognize patterns and make decisions. But how do they really operate? At the core of a neural network are neurons, which are the basic units that receive input, process it, and pass on the output. Picture a light switch. When you flip it, electricity flows and the light turns on. In a neural network, when a neuron receives enough input, it activates and sends its signal to the next layer of neurons. This is called activation, and it's crucial for the network to learn. Now let's talk about layers. Neural networks are typically structured in layers. An input layer, one or more hidden layers, and an output layer. The input layer takes in raw data, like images or text. Each neuron in this layer transforms the input into a numerical value. Then the hidden layers do the heavy lifting. They analyze the data, extracting features and patterns. This is where the magic happens. The more hidden layers there are, the more complex patterns the network can learn. But how does a neural network learn? It's all about training. During training, the network is fed a massive amount of data. It makes predictions, and then it gets feedback on how accurate those predictions are. This feedback is crucial. If the prediction is wrong, the network adjusts the weights, the strength of the connections between neurons, using a method called backpropagation. Think of it as a coach giving feedback to an athlete, helping them improve their performance over time. One fascinating aspect of neural networks is their ability to generalize. After training, they can make predictions on new, unseen data. This is what makes them so powerful in applications like image recognition, natural language processing, and even self-driving cars. They can identify a cat in a photo or understand the sentiment behind a tweet, all thanks to the patterns they've learned. However, it's not all smooth sailing. Neural networks can be prone to overfitting, where they become too tailored to the training data and struggle with new inputs. To combat this, techniques like dropout and regularization are employed, ensuring the network remains robust and adaptable. In essence, neural networks are like a complex dance of neurons, constantly learning and evolving. They mimic the human brain's ability to recognize patterns and make decisions, opening doors to innovations we once thought were science fiction. So, the next time you hear about AI or machine learning, remember that behind the scenes, neural networks are tirelessly working, learning, and transforming the way we interact with technology.